Alright, our goal in this case is to find the LCM, or the least common multiple, of these two polynomials, x squared plus 14x plus 49 and x squared plus 9x plus 14. The first step is to factor each of these polynomials. So in this first one we have x squared plus 14x plus 49 factors into x plus 7 times x plus 7. The second polynomial factors into x plus 7 times x plus 2. Okay, now we could get into kind of some very big jargon-based discussion about what an LCM is. But the way to think about this, I think, the most powerful, easiest way to think about this is you're going to create a polynomial here. We're going to write it in the factored form. But this LCM, it needs to contain each of these original polynomials. And the way that I do that is I'm going to just start with the first. So in this case right here I have x plus 7 times x plus 7. So I'm going to write that here. That ensures that this first quadratic right here is a multiple of what I'm developing. No matter what I add on here, that first polynomial, x squared plus 14x plus 49, is a multiple, is a factor of this multiple here. Then what I do, I'm going to add any factors of the second polynomial here that I'm missing. Well, since I already have an x plus 7 up here, I don't need to add that in. In fact, I have two of them. I have more than I need. But I don't have this x plus 2 part. So what I'm going to do is add in x plus 2. Again, big picture of what this is, and this would be my final answer for the least common multiple. This is a polynomial that when I look at the factored form of the LCM and the factored form of these two quadratics, I can find those two quadratics here. So for instance, that first quadratic, as I said, is right here, x plus 7 times x plus 7. The second quadratic is right here, x plus 7 times x plus 2. A very common question that students ask is, well, why didn't I add another x plus 7 in? Well, it's a big part of the L here. This is the least common multiple. It actually would be okay if I wanted just a general multiple to add on another factor of x plus 7. But if I'm trying to find the smallest thing that contains both of these, there's no reason for me to put in another x plus 7 since this already has one of those. And again, I look at this, both of those quadratics in their factored form can be found in this expression, x plus 7 times x plus 7 times x plus 2 is the LCM. Just a little fancy way of writing that as a final answer if I wanted to, I could write that as x plus 7 squared times x plus 2.